Hi, my name is Kayla, and I worked on this project with my advisor Seth Cooper at Northeastern University. So this project, it has to do with parser-based interactive fiction, which is the style of text-based games where a user types commands into a prompt and gets results based on typically a set of predefined objects that are available in the world and actions that are available in the world. And typically in these systems, they kind of have a discrete world model where there's a number of locations that can be navigated between, and in each location, there might be a number of objects, but you only have access to the objects typically in the location that you're currently in, and you can't access any objects in other locations. At the same time, you have access to all of the objects in a location equally, and there's no distinction between where in a location an object is located. So I have a diagram here that shows an example of two ways you could design the same game that has a wide open space with many objects in that space. An author is kind of faced with a choice of they either make one big location, in which case every object in the big field is equally available. Even if the player might think of themselves as being far away from a gazebo, they can still pick something up in the gazebo, even though they're thinking of themselves maybe as at the pond, because it's one big location. Or the author could create two separate locations in the field, one with the gazebo and one with the pond. But in that case, even though the game might say that you can see the gazebo from the pond, you won't be able to examine or interact with it in any way, even though you would think that you would be able to see that. And to get around this, authors have to come up with kind of ad hoc rules for when things are visible or interactable from between different locations. So my idea was to instead have a continuous two-dimensional world model underlying the game, and have the visibility and interactability of objects be determined using raycasting. So only objects that are close enough and that aren't occluded by other objects are visible in this system. And we came up with the title for the project, Isofict, from the term isovist, which refers to the visible volume around a point. So the way we implemented this was we made an Inform 7 extension with a JavaScript library. The reason we chose, yes, Inform 7 again. The reason we chose Inform 7 is because it's such a popular language for writing parser-based interactive fiction, and it's designed to be friendly to beginners. So we wanted to take that same beginner friendliness as something that is a goal of this project, is for it to not be super intimidating and not be really difficult for people who are non-programmers to use. So here is a system diagram that we have. What the author is responsible for currently is a JSON world model, which is just a set of objects with the coordinates that they're in and a definition of the polygon that defines the shape of the object. Or shapes. An object can have multiple shapes as well. And obviously the game itself. And in the game, they need to add certain basically tags to make it recognizable by the Isofict system. Isofict provides a JavaScript library that handles the 2D visibility because Inform 7 is not well designed for that kind of calculation. As well as an Inform 7 extension that provides functions that an author can call from their game without having to interact with the JavaScript directly. And finally, we also have a JavaScript-based front end that allows players to interact with the game using mouse clicks and WASD commands instead of typing in the commands. And the reason we chose to do that is both to eliminate guess the verb issues and because it can be a little bit frustrating to navigate around a 2D space, typing every single movement, type go left, enter, go right, enter. And you'll note this Vorpal. Vorpal is an existing API for translating between Inform 7 and JavaScript, which we used in this project. So we did a couple of case studies using this system. The first one that we did is Stately Gardens, which is an Inform 7 demo game, which takes place in a wide open field. That in this game is made up of multiple locations and uses an ad hoc rule for defining objects are visible if they are above a certain height and there are a certain number of locations away from each other. So that's the kind of ad hoc rule that we are trying to avoid. And so we made a case study where we re-implemented it from the ground up using the Isofict system. We found that it worked. Not too much information here with this because we moved on pretty quickly to Cloak of Darkness. So Cloak of Darkness is what has been called the Hello World of interactive fiction. It has been implemented in many different parser, not just parser, many different text game languages. And basically the game is a player is in an opera house wearing a dark cloak. And while they're wearing the cloak, if they enter the bar of the opera house, it's dark, they can't see anything. They have to hang the cloak in the cloakroom in order to make the bar visible. And we took Cloak of Darkness is implemented in Inform 7 and is provided in the Inform 7 documentation. We took that game code and edited it directly, trying to make as few edits as possible to use the Isofict system. So we created the JSON world model, and then we edited the Inform 7 code as little as we could to make it work. So here is the starting screen for our version of Cloak of Darkness. To the left, that is the map of the world. The big boxes are where the different rooms are divided. So the player starts in the foyer. To the left, there's the cloakroom, and below that, there's the bar, which is dark. And that huge rectangle in the bar is the message in the bar, which if the player tramples it, they won't be able to read it. And then here we are, again, we have gone into the bar and it is in the dark. You can see that the red dot that represents the player is in the bar. You'll also notice these kind of colored triangles that are surrounding the player. Isofict provides the ability to have multiple different perspectives for the player. So there can be a front, a left, a right, and this is configurable. We just use a front, left, and right, and then anything that is in that back quarter is just not visible. You'll note that the message on the floor is only going to be scuffed if the player actually walks on it, which I'll show you the code for in a bit. In the original game, it's just based on how much time the player spends in the darkened bar, they can trample the message. Here you see the player is in the cloakroom and they can hang the cloak on the hook, thereby lightening the bar. Also, you can see that the way Isofict describes the location is it takes those different perspectives and describes what is in each perspective. And the directly in front of you versus further back is based on a configurable closeness parameter. So things that are closer are described as being directly in front of you, and things that are further back are described as being further back. And similarly for the right and the left. So once you have hung the cloak, you go into the bar and it's lit now. And if you have trampled the message, you lose because the message is trampled and can no longer be read. If you did not trample the message by the time you read it, you won. So here is a bit of a code example of the kind of what we found pretty minimal changes needed to the Inform 7 code to make the game work. You see that there are these tags that are added to the game. So things like saying things are geometric, saying that you're going to geo-hide things. Those are Isofix terms for putting things into things that the JSON world model and the JavaScript code will recognize as being part of the game. Here is the part about the message. So again, as I mentioned, we made it so that only when the player actually walks on the message do they trample it, which is the kind of thing that is can only be done if you have this kind of 2D world model available. Here's just the JSON world model. So just a set, the objects are just a set of coordinates with their polygons, which are more coordinates. And then this is an example of the player perspective. So it has different regions that are available to it, and you can define what angles the regions take place in. A couple of issues that we have is some Inform 7 features are still not fully implemented. And there's also some surprising visibility behavior. For example, if you are really close up, you can see in the top right, if you're really close up to a large object, it will be described as being to your right or your left. This is because the way that we decide which perspective an object is in is based on how much of its perimeter is in that perspective. Also, if you have a line of very small objects, they can occlude each other because the 3D heuristic for height is just very simple. If something is taller than something else, it occludes it. It doesn't have any perspective of how tall the player is. And this is because it's not true 3D, it's just a heuristic. So in our future work, we would like to study this in a user study and explore what it feels like to play a game like this, also explore what it feels like to author a game like this. We want to improve some of these visibility heuristics, maybe introduce an actually 3D model that uses actual 3D visibility code instead of this kind of heuristic-based approach. And we are also interested in exploring what other kinds of experiences this could enable, especially if we've explored taking a traditional parser-based game and turning it into a giving it this 2D model. We're also interested in if we took a 2D game and translated it into a text game with its existing model. And if you would like to play Cloak of Darkness with this system, you can do it at this QR link. Any questions with the remaining time?